Hello friends, today we are going to talk about the liquid filled thermometers, one of the most widely used thermometers in day-to-day life, or in many of the our physics laboratory or even in the chemistry laboratory as well. Okay, so it is also known as the volumetric thermometer, or else the field thermometer is also known as. Okay, so liquid is filled inside it as a expansion material. Okay, volumetric thermometer. What is the working principle for it? Let's see. Okay, so it is actually the based on the principle of the thermal expansion. That is, there is a fluid expansion because of the increase in the pressure in a given volume of the temperature. So temperature measuring system. Okay, now let's try to understand the construction of the this type of the thermometers. Okay, so if we look at this diagram, we can see over here this temperature scale bar, then this is a pointer. Okay, this is pointer which is pointing on the or pivoting on the scale bar, and then now we can call it as a Verdon kind of the tube or the tube. Okay, is then the Verdon tube is there, and then connectivity between this to the through this Verdon kind of the tube to the bulb and the liquid which is filled inside that bulb. So this is a working construction of the this liquid filled thermometers. So actually it consists of a kind of the metal bulb. Okay, metal bulb containing the liquid. So bulb can be made up of the this can be made up of the stainless steel or the brass or the monel or the nickel kind of the materials which will be used for the making the this this container, or we can call it as a metal bulb. Okay, note that here the depending upon our corrosion type or the wear the strength required, so on that basis we can choose the bulb material. Okay, means here we are going to use these thermometers. So capillary tube is made up of the stainless steel. So this is a capillary tube connectivity between this pointer and the Verdon tube. Okay, or through the through the Verdon tube to the bulb. So capillary is made up of the copper, steel. Okay, for protection it can be or it will be enclosed in armor, and it is installed carefully to avoid the damages. Okay, so Verdon tube is used as a pressure sensing device which converts the pressure into the displacement. So what here, so whenever there is a temperature across this bulb is getting changed, so liquid get expanded. Because of this, the what we can see, we can there will be the generation of the pressure, and that pressure will get developed through this Verdon tube, and it is connected to this kind of the mechanism over here, and it gets the spring will get just expand or the just wind up or the unwind it, and because of this the pointer will just move on the temperature scale bar. This is actually the principle of this liquid filled thermometers. Okay, so let's talk about the little bit working principle and some mathematics related to it. Working depends on the volume change of the liquid with the change in its temperature. Already we have seen in how it is just getting the liquid is getting expanded. So the equation of the volumetric change with the temperature is given as Vt is equal to V0 into 1 plus beta T. Here we will be having the some notations regarding the various terminologies here used, or the variables we use. That is, Vt is equal to Vt is nothing but the volume at the temperature T degree Celsius. V0 is the volume at the temperature 0 degree Celsius. Beta is the coefficient of the cubical expansion, and T is the rise in the temperature. So here commonly used liquids are generally mercury, ethyl alcohol or ethanol, toluene, then we can have the xylene. Okay, so and it should be noted that here is that the ethyl alcohol or the toluene have volumetric expansion. Toluene has a volumetric expansion 6 times greater than the mercury one. Okay, if you just try to compare the commonly used mercury, it has a volumetric expansion of the 6 times than the mercury one. Or liquid is normally put under the pressure, and it is completely fills the bulb and the tubing one. So liquid generally completely fills this liquid and the tubing here used. Okay. When the bulb is immersed in heated substance, or when the bulb is immersed in a heated substance, the liquid expands, causing this burden tube to unwind or wind. Okay, so here the sensing device acts as a differential volume indicator. Okay, sensing device is acting as a differential volume indicator, and response is linear to the temperature changes. So whenever there is change in temperature, obviously this response is a linear one. Okay, so the and it is a very important thing to be held in this liquid filled thermometers. Then if we just look at the ranges of the different kind of the materials we used as a liquid in the thermometers, as xylene has the temperature range from the minus 40 to 750 degree Fahrenheit, or the ether we can have the temperature range from the 70 to 145 degree Fahrenheit. Okay, not the Farad, sorry, Fahrenheit. And the alcohol has the temperature range from 155 to the 260 degree Fahrenheit, and the mercury does have the temperature range from the minus 38 to the 1000 degree Fahrenheit. Alcohols actually alcohol thermometers are used in the cold countries to measure the low temperature near to the ice point. Okay, and what are the advantages of using this kind of the thermometers? Is nothing but it expands uniformly, large expansion or expansivity, and it has a lower freezing point around minus 115 degrees Celsius. And if we look at the disadvantages of it, as actually it wets the tube, then it has a low boiling point, that is 70 degrees Celsius, and the high specific heat capacity. So this is all about the liquid filled thermometers.